Hello everyone and welcome to this introduction to our Python library, Deep GIS, designed specifically for land use classification. This library provides a streamlined and efficient approach for handling remote sensing data, supporting key functions such as land use classification, land dynamic analysis, and land use change detection. In this video, I will walk you through the structure, usage, and main applications of the library. The library is structured for clarity and efficiency with dedicated modules for configuration, training, inference, and analysis. Its core files include the config, trainer, and predictor modules, all of which facilitate a customizable end-to-end workflow. And our config module allows users to define parameters for datasets, model architecture, training specifics, and inference settings. Let's look at the main components of the code. The config module enables users to control parameters using JSON file, which cover aspects such as login path and module storage locations. We provide two models. One is chain and the other is inference. The library includes two pre-trained models. The first type is MobileNet v3, which contains two types of networks. One is v3 large and the other is v3 small. The second category is ResNet, which has 5 variants. Users have the choice to either train these modules from scratch or use the provided pre-trained weights. The training process is managed by the trainer class, which organizes all steps based on the train and test functions. The prediction functionality is handled by the predictor class, allowing users to complete the entire inference phase with a single function call. Now, let's see how to execute the code. The implementation of code is mainly divided into 4 steps: model configuration customization, model loading, land use prediction, and land use analysis. We start by loading the config file, where we define the parameters for either training or inference mode. Once the setup is complete, we load the model and initiate the training process. The progress is tracked through a real-time progress bar, allowing users to monitor the training in detail. After the training is complete, users can switch to inference mode, where they can apply the trained model to make predictions on new data. Finally, they can save the result as GLT files. This library is ideal for 3 primary applications: land use classification, land dynamic analysis, and land use change detection. First is land use classification. This is achieved through the model's ability to process remote sensing data, identify different land use types based on predefined categories. The figure shows the model's land use classification results of Guangzhou city in different periods. A comparison of the 2 sets of images indicates that built-up area and vegetation were identified and classified reasonably well. The library also supports assessing land dynamics over time, allowing users to quantify the extent and nature of changes in land use categories. The findings indicate that from 2015 to 2022, the comprehensive land use dynamic index gradually decreased, suggesting a reduction in the intensity of land use changes. Lastly, the change detection feature enables users to compare imagery from different time periods, identifying significant shifts in land use. This tool facilitates the identification of areas where one land use type has transitioned to another over a defined period. By visualizing these transformations, the tool enhances the understanding of spatial development trends and aids in the assessment of urban growth patterns. In conclusion, I hope this video has provided you with a clear understanding of its structure and practical applications. We aim to continue enhancing the library's capabilities, making it a valuable tool for more complex analysis in the future. Thank you for watching, and if you are interested in learning more about Deep GIS Library, feel free to explore it further or even contribute to our ongoing work.